Hello students, Dr. Mayadun here. I am going to show you the chapter 9, solution concentrations. In this chapter, we talk about solution concentrations including mass percent, molarity, molality calculations. And I want to show you how to find the mass percent at the beginning. So how to find the mass percent? Mass percent is how much percentage of mass of solute in that total solution. So the equation is mass of a solute divided by mass of a solution. So solution include solute and a solvent. So we learn about solute is the when you take a solution, think about sugar solution. Solute is the sugar, solvent is the water. Solute, which one is the small amount, which is the minority. Solvent, which is in the majority. So you add these two together and divide. So first take mass of a solute, divide by the mass of a solute and solvent, and you multiply by 100 because it's a percentage. So let's look at the question. Determine the percent mass, the percent by mass of concentration of each of the following solutions. 25 29.5 grams of magnesium chloride dissolve in 100 grams of water. So in this one, you see what is the solute? Solute is magnesium chloride. Magnesium chloride divide by mass of magnesium chloride divide by mass of what is a solute, but you have to add the mass of a solute too. So you get the 29.5 divide by, add 29 to 100 grams, you divide and you get the answer. And you have to multiply by 100 because it's a percentage. Let's look at that. 3.72 grams of carbon dioxide dissolving 500 grams of water. You get mass of a solute divided by mass of a solute plus mass of a solvent. And then this one, it's in the milligrams. You just do the same thing because it just not make a big difference, just a smaller amount. So let's look at the same thing what I told you earlier. So they find, okay, this is the mass of a solute, this is a mass of a solution, and then equation, mass of a solute divide by mass of a solution, which is in this particular case mass of a solute is 29.5, divide by 29.5 plus 100 into 100 because it's a percentage. So this is how you find the percentage, mass percent of a solution. And if you want to go to another type of calculation, in this one, determine the mass of a solute present in each of the following aqueous solutions. So here my question is 250 grams of solution, that is 11.8 sodium nitrate by mass. So here we have, so when we write the equation, you write, okay, the mass percent, we try to write it here. So I hope you can see. Let me give it a try. So let me share my screen. Okay. Okay. So I want to I don't want this one. It's okay. So I want to show you the 250 grams. I couldn't, I'm sorry, I couldn't get the, okay. So here my question, it is, I don't need this one. So determine the mass of a solution in 250 grams in 11.8 sodium nitrate. So it is 11.8 sodium nitrate, my percentage. Let me write my percentage here. Get a different color. 11.8. Okay, that's percentage. Before I forget, I want to write it down. So now my equation for mass percent is it's okay. Let me take this. So 11.8, and then it's 250 grams, right? So the mass percent is mass of a solute divided by mass of a solution. Okay, so mass of a solute, and so here mass percent is given, which is 11.8 into 100 you have, divide by mass of a solute, you don't know. Just think about mass m here, and then the mass of a solution, I know it's 250 grams, and then you multiply by 100. So you solve this equation, you get the mass of solute. Yeah, so you get the mass of a solute here. You multiply, it's 0 goes away, and then can I divide by 2, I divide by 5, I try to simplify it. Divide 5, and then you multiply 11.8 by 5 and divide by 2, you get the mass. So again, I'm showing here in the detail calculation. So 11.8. See, this is how you do the calculation. Is the same way we did the calculation. 11.8. So this is the solution, and then you get the answer. What is the mass of the sodium nitrate in the solution? So they did little bit differently how I did. So if I write it again and showing you the mass percent, which is 11.8, I can show you this. It's the same thing. It's divide by you don't know the mass of a solute, divide 250 into 100. So it's the same thing. That's what I want to show you. 11.8 multiply by 250 divide by 100. I just simplified. So how do I simplify? How did I simplify it? 0, 0 cancel out. 2, because I divide by 5. 5 into 5, 5 into 2. So 11.8 divided by 5. Then 11.8 multiply by 5 divide by 2, you get the answer. So that's how you do this kind of a mass percent questions. The only thing you need to know is important. You need to know what is the equation. So what is the percent by mass is mass of the solute divided by the mass of a solution. With that, I'm going to the next one, which is the molarity. The molarity also important. Molarity, number of moles divided by the liter of the solution. So number of moles divided by the liter, the volume of a solution. We write sometimes, okay, molarity, we show in the lowercase m, the uppercase m, sorry. It's going to be uppercase m. Number of moles divided by volume, or you can write it's another. So this is n is the number of moles. It's not the good color. Get this one. Number of moles divided by volume, you get the molarity. And then I go back. So if you do a calculation from that, so it's the determine the molarity of the following glucose 0.223 moles divided by volume, you get the equation, which is 0.2 molarity, number of moles divided by volume in liters. So it's 0.223 divided by 1.5. You should get your answer. I'm going to show you how to do the part C. 136 grams of glucose in 750 milliliters of solution. So in this particular case, I want to write it down. 136 in, I think, 250, 750, yes. It is 136, 750. I'm going to do the part C, okay? 136 in water. So first things first, I want to find the number. So what is the how to find the molarity? Number of moles divided by volume. Number of moles divided by volume. I don't know the number of moles. How to find the number of moles in given mass divided by molar mass. So what is the molar mass of glucose? Glucose is C6H12O6. You don't have to memorize it. You can look what is the formula for glucose, and then you can add these numbers, which is 12 into 6 plus 1 into 12 plus 16 into 6, which gives me 180 grams per mole. So it's grams per mole. I write that, and then I get that. This is the molar mass. Given mass is 136. Divide by 180. I get the number of moles. So once I have the number of moles, this is the grams per mole, and then grams cancel. I'll get the answer in moles. Once I have the moles, I go to the next one. Next page. Yeah. So once I have the moles, I use the my concentration, molarity, number of moles divided by volume. Volume is given in the milliliters here. It's given in 750. So I need to convert 750 to liters. How do I do that? Milliliters to liters. Easy way I'm thinking how to convert milliliters to liters is, I think, okay, the big Coke bottle is 1 liter. So, but it has 1000 milliliters. So, I always, milliliters to liters, I divide by 1000. I divide by 1000. So, it's going to be 0.75 liters. I find the number of moles in the previous calculation, divide by volume. I get my answer. So, if I go back, okay, then yeah, then I go up a little bit. Okay, we were here. So this is the number of moles, 0.755 moles of glucose. You divide by the volume, you get the molarity. So that's how you find the molarity. And then so in this way, it has determined the volume each of the solution that contains 0.313 moles of solute. So it's given the molarity. So you use the no, let's go there. So then the molarity is given. So you know molarity M equals number of moles divided by volume. Already volume you know. The volume you have to find the molarity. Sorry, you have to find the volume. Number of moles is given. So you go back. You see here. If you go there, you see, okay, the number of moles. So it always says set up 1 liter contain this many moles. Let me explain you again. In this way, so this is easier. So number of moles is given here. So if I write here, so you know number of moles equals, so molarity equals number of moles into volume. Okay. So in this one, then you know the molarity, which is in the part A, 0.04 0.0448 is the number of moles, molarity, and the number of moles is, I think it's given here, 0.313. Save it. So, I want to save it here. So I forgot the numbers. That's why when I go there, 0.313. Okay, so this is the number of moles. So C concentration molarity is number of moles divided by volume. Concentration 0.0448 equals number of moles 0.313 divided by volume. You take the volume to the other side. 0.313 divided by 0.448 will give you the volume. That's how you find the volume. Okay, let us save it. Okay. Then I'm going to show you the molality. Molality um, and molarity. This should be changed. It should be molality. Molality is lowercase m. It shows mole of a solute divided by the kilogram of solvent. It's different than molarity, and molality is different. Molarity, we took the volume of the solution. Here we take the kilogram of solvent. If I do the little calculation, determine the molality of each of the following solutions. 0.253 moles of sucrose in 1.75 grams of kilogram of water. You take the moles, divide by 1.75. But if you take part C, 12.1 gram of methanol in 275 grams of water, you have to convert 12.1 grams to number of moles by dividing molar mass of methanol, which is CH3OH, and then divide by the kilogram of water. So you have to convert grams to the kilogram. So if I show you here, part C, you take the number of moles, which is by given mass, divide by molar mass, and then divide by the mass of the solution. So that's how you do this kind of setup of calculation. Before I move on, I want to show you the dilutions. Dilutions also play a very important part, which we use only molarity in chemistry labs. Dilution is very similar, that you take orange juice frozen concentrate, that's very small volume, and then you add water to make the dilute solution. So in the what is this dilution is, always in dilutions the amount of solute is constant. The change is volume and the concentration. Think about frozen orange juice container, the which you buy from the store. It's very small. It is very concentrated. Volume is small. High concentration, small volume. When you make the orange juice, you pour that the same amount, and you add more water. It changes the concentration and it increases the volume. So always in any dilution, we keep the number of moles constant. So that's how we do this calculations. Yeah. So we compare the M1 V1 equals M2 V2. Here it says MC, molarity of the concentrated solution, volume of the concentrated solution, molarity of dilute, volume of, like L means liters. So if I take this example, what volume of 12 molar HCl, a common laboratory stock solution, must be used to prepare 250 milliliter of this much. So, how do I do that? Let me see whether I can open it. I can see whether I can take this side. Okay. So, my numbers 12. So, what volume? 12. So, you see, this is the concentrated one, right? 12 molar HCl. What volume of 12 mole HCl, a common laboratory stock solution, must be used to prepare 250 milliliters? This is the volume of the dilute solution, and this is the concentration of the dilute solution. You see, this is 12, 0.125. 12 is high concentration, so the frozen concentrate, and this is the dilute concentration. So you need to do MC LC, like volume, and then MD, which is dilute solution, and the volume. We already know concentrated. What is the concentration of the concentrated solution? Only thing we are looking is the volume of the concentrated solution. And this is the in um, concentration of the dilute solution. This is the volume of the dilute solution. So I think I have the numbers. I'm going to show you how to do it. I would write M1 V1 equals M2 V2. This equation, some professors they say C1 V1 equals C2 V2. I know my M1 is 12. I don't know the volume. But M2 is 0.125 into 250 milliliters. You may wonder why I use milliliters, because I get the volume. When I get the volume, it doesn't matter I use milliliters or liters, because the units cancel out. So in this equation, you can use milliliters or liters. If you use milliliters for volume, you get the answer in milliliters. If you use liters, it will get the answer in liters. So I get 12. So 0.125 multiplied by 250 divided by 12, you get the volume in this way. So this is how you do this kind of calculation. So I hope this video will help you to understand chapter 9, and thank you.